Hi, boys. So we're going to go and review chapter 3. So last week you reviewed chapter 2, and then this week we're going to do a combination of chapters 3 and 4. Okay, so these notes should look very familiar to you, but I just wanted to do a short video, and I also will post the notes for these individual lessons. Okay, so again, none of this should be new to you. We have done all of this before. So chapter 3 was about functions. Okay, so today you're going to learn pretty much, relearn what a function is and all the different characteristics of functions. Okay, so let's get started. All right, so we do have some vocabulary. So first thing is a relation is something that pairs inputs with outputs. Okay, so you put something into a machine and it's going to then spit out an output. Okay, now when a relation is given as ordered pairs, the x coordinates are the inputs and then the y coordinates are your outputs. So for example, if you have, your x comma y and you had 2 comma 4, well, 2 would be your input and 4 would be your output. Now, if a relation that pairs each input with exactly one output, so this is something that is super important right here. Whoops, sorry about that. So pairs each input with exactly one output. If that happens, it is then called a function. Okay? So here are some different ways of describing a function. So a function can be described as an equation, an input-output table, which you'll see today, a mapping diagram, which you'll also see today, a graph that you'll see, a set of ordered pairs, and then using words. So there are 6 different ways that you can see a function described. Okay, so let's kind of relate this to real life, and you probably will know this. Well, it should be remembered. Is you have a birthday function. Okay, so let's just talk about that you only have one birthday, and no, half birthdays do not count. Okay, so if you look at this function, you have George Washington that is being paired with February 22nd. That's his birthday. Marie Curie has a birthday on November 7th. Charles Darwin has a birthday on February 12th, and so does Abraham Lincoln. Now, that is allowed because each person has their own birthday. And yes, 2 people can have the same birthday. But what can't happen is this. You can't have Abe Lincoln having a birthday on November 7th and November 12th. So that would not be allowed. Okay? So each person has exactly one birthday, so it represents a function. And obviously, like I said, one person cannot have 2 birthdays. All right, so here are some examples. So pretty much I want you to determine whether the relation is a function. So if you look at this input table, I do believe that all of these have an arrow that's being pointed to them in the output area. So it's like all of these numbers right here all have birthdays. In the other input table or input diagram per se. So yes, it is a function, and the reason is every input has exactly one output. Okay, so you're gonna have to remember, kind of know what words to use in your big ideas assignment today. Okay, so if you look over at B, look at all of your X's. So you have 4, 8, 6, 4, and 5. Notice how I repeated the 4s. So you can't have the same 4. So think about this. You have a 4, an 8, a 6, a 4, and a 5. Okay, well, obviously I don't need to write 4 again, so I'm just going to get rid of this. And so this would be your input. Now your output would be your 0, 7, 4, 3, and 2. So 4 would go to 0, 8 would go to 7, 6 would go to 4, 4 would go to 3, and 5 would go to 2. Now notice, this 4 cannot have 2 birthdays. So this 4 and this 4 are what violates the problem. Okay, so no, it is not a function. And the reason is the input 4 has two outputs, which was that 0 and that 3. Okay, so let's do another example. So this is an example of another table. So if you look at all your inputs, I don't see any repeats except for these double zeros. A 0 cannot go to 5 and cannot go to 6. It can't happen. A 0 can't have two birthdays. So no, it is not a function because the input 0 has two outputs. Let's look at letter D. I see -2, -1, 0, 1, and 2. Oh, look, no repeats. So this is a function, and every input has exactly one output. Okay, again, you need to memorize these words. You're going to use them in your big ideas assignment. All right, now one more concept of functions was that vertical line test that we talked about months ago. So for a graph to be a function, it has to pass the vertical line test. So no vertical line can pass through more than one point. So if you look at this red dotted line, that's okay because it only went through one point. Okay, but if you look at the second example, this dotted line goes through 2 points. So it cannot go through 2 points. It can't even go through 3. 1 is the limit. Okay? So here we go. So first example, let's draw dotted lines. Dotted line, dotted line. Uh-oh, I see 2 violations. Forgot this one too. I see this one and this one. And this one is this and this one. So it doesn't matter. It's not a function because you can draw 2 vertical lines. Okay, even if I drew 1, you can't do that. Okay, it can't go through 2 points. Let's look at letter B. Letter B, if I draw a line through every single one of these, oh, looks good. It didn't go through 2 points. So yes, it is a function because you cannot draw a vertical line. I have 2 more left. So let's look at this one. It's a sideways parabola. Oh no, look at all these lines. It violates it several times. Look how many lines I can draw. It violates it several times. So no, it's not a function because you can draw several vertical lines. Let's look at letter D. Letter D, line, 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 line. Oh, looks like we're good. It only went through 1 point. So yes, it is a function because you cannot draw a vertical line. All right, so your assignment is on big ideas. And remember those keywords that I told you to remember. And I will see you next time.